Based on the data from water.org, about 18 million Indonesians lack safe water and 20 million lack access to improved sanitation facility, one of which is laundry liquid waste.
The emergence and along with the rapid increase in laundry services causes water quality degradations and become catastrophe for the ecosystem sustainability. Most of this laundry business does not recycle laundry waste, but these waste is directly disposed of into the outlet drain pipe, also known by runoff. Laundry liquid was contaminated with various hazardous chemical substances, one of which is surfactant and phosphate. The runoff the spread of phosphate-containing laundry detergents will cause eutrophications which lead to algal blooming on the surface of water, turns to reduced oxygen levels in the water. According to the U.S. Environmental Protection Agency, EPA, surfactants break down the mucus layer that coats fish, protecting them from parasites and bacteria.
Therefore, to overcome the problem that have been described, we are proud to present an innovation entitled
Reductions of surfactant and phosphate levels in laundry liquid waste using multi-soil layering based on sulfur mud from Krung Raya Hot Springs, Aceh Besar. My name is Muhammad Zawil Wafa Hafizh,
and my name is Muhammad Fathur Rizqi.
We are from Fathur Senior High School.
Multi-soil layering is a processing method that utilizes soil as the main medium, which is involved in a brick construction consisting of layers of mixtures of soil with 10 to 35% iron particles, organic matters, and a layer of pellet which is equipped with two perceptive zones, namely the aerobic zones in the pellet layer and unaerobic zones, the soil layer.
And why do we choose sulfur mud? Sulfur mud from Krung Raya Hot Spring as the base for MSL system is a perfect composition. Sulfur mud is categorized as andosol soil. Andosol soil are the most commonly used soil group in the MSL system because andosol soil has the ability to be contaminated with very small chemical substance.
The purpose of these experiments are to analyze the effectiveness of the sulfur mud-based MSL system from the Krung Raya Hot Spring Aceh Besar in reducing the concentrations of surfactant and phosphate level. Second, analyzing the changes in the concentrations of surfactant and phosphate levels in laundry liquid waste during the trial period. Third, observing the conditions of the sulfur sludge-based MSL systems during the trial period for changes in the concentrations of surfactant and phosphate level in the laundry liquid waste. Fourth, achieve 2 goals point of the 2030 Sustainable Development Goals SDGs, namely clean water and sanitation the 6th point and land below water the 14th point.
This project conducted in 3 stages. The first stage is to collect all material that is needed. The reactor container of MSL system is designed in the size of 60 cm x 30 cm x 40 cm, with glass as the base material of the reactor. There are 2 pipe fittings in the reactor. Erection pipe as the main function is to speed up the aerobic process inside the reactor, and outline pipe is used to drain the purified water after passing through the MSL system layer. The last step of this stage is to print 12 multi-soil blocks with sulfur mud and play with the provision of a predetermined amount of composition at a ratio of 50 to 50 in the size of 15 cm x 10 cm x 5 cm.
The second stage is to arrange the MSL layer. At the lowest layer, we fill it with gravel as deep as 5 cm. On the second layer, we fill it with perlite as deep as 5 cm. In the third layer, we coat it with 6 MSL block prints. And on the fourth layer, we cover it again with perlite with the same depth, which is 5 cm. We also did the same sequence on the fifth, where it's covered by 6 MSL blocks. The highest layer is filled with perlite as deep as 5 cm.
The last stage is to do the laundry liquid waste treatment. First step is to take the sampling of laundry liquid waste using a scoop and put it into jerry cans with a size of 10 liters from laundry waste disposal pipe of the laundry business. Next step is to follow the work procedure for treating wastewater using the MSL reactor. Can be carried out with the stages of preparing laundry wastewater based on each volume of wastewater to be added 1.5 liter, 2 liter and 2.5 liter. The laundry liquid waste is then precipitated in the MSL reactor with predetermined detention times of 15 minutes, 25 minutes and 35 minutes The laundry waste that has gone through a MSL process is put in a sample to analyze the contamination number of surfactant and phosphate, as well accompanying parameters, namely testing for pH and ESS level.
The surfactant and phosphate level test was carried out in the MIPA Unshiah Laboratory and Unshiah Environmental Quality Testing Engineering Lab with the help of a spectrophotometer to calculate the levels of surfactant and phosphate concentration. The following are the results of the analysis of laundry waste before being processed in AMSL systems, which can be seen in the following table. There is a significant decrease in the surfactant levels. In the following table, it can be seen that the most optimum results were in the treatment of sample variations of 2.5 liter over 35 minutes, with a decrease until 1.08 mg per liter, where this figure was below the quality standard per man LH number 5 2014, which is 3 mg per liter. We can see in the graphic results that there is a decrease in the calculations of the phosphate level. It can be concluded that the most optimum sample treatment is in the sample variation treatment of 1.5 liter over 35 minutes, with a decrease in phosphate levels of reaching a value of 1.25 mg per liter, where this figure was below the quality standard per man LH number 5 of 2014, which is 2 mg per liter.
The pH test was carried out as a measurement of the range of pH value. Before the treatment or control was carried out, it could be seen that the pH value reached 9. And it can be seen from the result after the treatment. The MSL system was able to neutralize the laundry liquid waste.
The TSS test is performed as a measure of water clarity. The results obtained from the TSS test are amazing, where there is a decrease in TSS levels. Prior to the treatment, the total suspended level reached up to 127 mg per liter. After treatment with the MSL systems, it can be seen that the most optimum treatment is 2.5 liter over 25 minutes and 2.5 liter over 35 minutes. It's decreased to 50 mg per liter. This shows that the final sample is clearer than the control sample or before treatment.
The conclusion are: we also recommend that during the research process, suggestions that can be shared are. We also hope that we can improve our project. Thank you.